Hey guys, so before we start talking about initial conditions and finding like exact answers for antiderivatives, I actually want to explore this idea of that plus c constant of integration a little bit more. So let's say we have a function, something like f of x equals 2x. Not super difficult. I can tell that if I take the antiderivative of that, I'm actually just getting x squared. But then there's that kind of weird little plus c at the end. So I want to explore what that means a little bit. Right now I have the derivative function graphed in red, and now in blue I have our original function graphed. So kind of that x squared plus c situation. Confirm in your heads real quick that 2x is the derivative of x squared. Okay, so what I'm noticing here is that this plus c, like c could technically be any constant number. Because anytime you have a constant, it doesn't change the shape of your graph. It just changes where it is. So take a look here. I've added plus c onto my antiderivative function, and Desmos is very cool. It gives me this little slider thing here. So I'm going to slide this function around. And in fact, I'm just going to get rid of that 2x. I really want to show you, and maybe I'll zoom out so you can watch it just move a little bit. But I want to really convince you that plus c really doesn't change the shape of this thing. It just changes where it lives on the graph. It could be up or down, and so it's really just where it lives. So the plus c, the x squared plus c, that represents kind of a family of antiderivatives, where it could be, the collection of all of these shifts up and down of the parent function x squared. So when we're talking about an initial condition, ultimately that's some kind of information about the original graph that tells me which one of these functions I'm talking about. Is it x squared plus 2, or is it the x squared plus 3.5, or x squared minus 5? Like, which x squared kind of function am I talking about? Which one is it? And so an initial condition tells us a little bit of information about, hey, where does it live on the graph? An initial condition might be something like 3 comma 2, or sorry, how about 3 comma 2, which is like that. And so maybe it's telling me, oh, your function goes through that point. So you need to shift your equation until it goes through that point. And now that's the one parabola I'm actually talking about. And the c value that is happening is actually negative 6.8. So notice how when I place a point on the graph and I say, hey, your function goes through that point, it now causes c to be a fixed value, not just any constant, but actually a specific one that puts your function right through that point. If I change c, let's say shift it around again, see how it's not going through that point anymore? So that's not the correct antiderivative. The correct antiderivative has to be the one that goes through that point, and so it's somewhere kind of close to 7. So I'll show you some algebraic techniques to actually use initial conditions and find which specific function we're talking about, not just a general plus c, but actually x squared plus 5 or something like that.